Welcome to Einsteinium theoretical physics. Let's understand around us. In this video, we will see the rise of Aristotelian physics. The journey of physics continued with the post-Socratic philosophers as classical philosophy, carried by the great philosophers like Plato, Eudoxus, Callippus, and Aristotle. Those started asking questions on human life. Where do we live? What is around us? How does the universe behave? As a single field of Western philosophy for science, religion, and philosophy. Timaeus, a most famous dialogues of Plato, says that the universe is the handiwork of a divine craftsman, the demiurge, who fashioned and shaped the material world as an eternal model of the cosmos by imposing a mathematical ratio on a pre-existent chaos to a beautiful orderliness. All the elements, the motion of the stars, the recurring seasons, the shape of flowers, the state of the world, all are derived from the model. Even in failure, creation gives a sense of order. Platonists, the philosophy of Plato, believe the sphere is the embodiment of perfection. Beauty, truth, and virtue come together. Plato explains that the cosmos is spherical. The sphere is described as the most complete and the most self-similar structure. Plato combined the pre-Socratic findings, the four elements of Empedocles, earth, air, fire, and water, the mathematical ratios of Pythagoreans, and the invention of the atomists, Democritus, the atoms of nature. He transcends that the cosmos is made up of two right-angled triangles, an isosceles and a scalene, from which the demiurge can construct 5 regular polyhedrons, tetrahedron, octahedron, hexahedron, icosahedron, and dodecahedron. These stereometric forms are known as Platonic solids. Plato expounded a theory of everything based explicitly on these 5 solids, saying that they have a connection with the fundamental building blocks, the atoms, and the 4 essential classical elements of the universe. Tetrahedron, with 4 faces, represents the element of fire, as it has a sharp, penetrating quality, balance, stable on a face, reminiscent of the heat, and has transformative power. Octahedron, with 8 faces, represents the element of air, attributing its lightweight and ethereal nature. Hexahedron, the cube, with 6 faces associated with the element of earth due to its stable and grounded nature. Icosahedron, with 20 faces, is associated with the element of water, as its smooth, flowing surface is reminiscent of the fluid nature. Dodecahedron, with its 12 faces, was associated with the cosmos and the 12 constellations. He believed it represented the celestial sphere and the harmony of the cosmos. The face of hexahedron is made of square, dodecahedron is made of pentagon, and others are made of equilateral triangles. Timaeus explains the intertransformation of elements can only be possible among fire, air, and water. Earth and cosmos cannot be transformed. Transformations can be described at the level of equilateral triangles. Fire molecule is made up of 4 triangles. Air molecule is made up of 8 triangles. Water molecule is made up of 20 triangles. Possible transformations are 2 fire molecules could combine to make 1 air molecule. That is 2 times of 4 triangles makes 8 triangles, which is an air molecule. Likewise, 5 fire molecules could make 1 water molecule. 5 air molecules could make 2 water molecules. 2 air and 1 fire molecules could make 1 water molecule. 3 fire and 1 air molecules could make 1 water molecule. The transformation of elements seems to violate the principle of conservation of matter, which states that the mass can neither be created nor be destroyed in an ordinary chemical and physical changes. 100 grams of ice should give 100 grams of water. But matter is not a concept Plato is working with. In his view, a material ultimately consists of triangular atoms composing the polyhedral corpuscles of the elements. Contained within these polyhedra is empty space, the receptacle as he called it. So it is not matter that Plato must conserve, but triangles. On his theory, when a corpuscle of water is broken down and converted into corpuscles of fire and air, all the original triangles in the corpuscle of water are conserved, and the triangles combine to form the surfaces of the polyhedra. Hence, it is not the total volume of his polyhedra, but their combined surface area that must be conserved. what remains constant in transformation? One of Plato's most significant contributions to astronomy was his claim that each planet moves on several circular tracks. In honor of this great influential Greek philosopher, European Space Agency, ESA, named their cosmic vision program as Plato, Planetary Transits and Oscillations of Stars. Archytas of Tarentum, Greek philosopher, mathematician, astronomer, and scientist affiliated with the Pythagorean school and famous for being the reputed founder of mathematical mechanics, the flying machines, and a friend of Plato. Archytas gave prime importance to the three mathematical means, the arithmetic, geometric, and harmonic, and he named the harmonic mean, which is important in projectile geometry and number theory. The harmonic mean is the reciprocal of the arithmetic mean of the reciprocals. Archytas solved the problem of doubling the cube, the so-called Delian problem, with an ingenious geometric construction. It is an ancient, impossible geometric problem. Given the edge of a cube, the problem requires the construction of the edge of a second cube whose volume is double that of the first by using only a compass and straight edge. Archytas' solution was remarkable by intersecting three surfaces of revolution meeting at one point. Archytas' demonstration, which uses lines generated by moving figures to construct the two proportional between magnitudes, was the first in which geometry was studied with mechanical concepts. Archytas was reputed to have designed and built a bird-shaped, self-propelled flying device known as Flying Pigeon, the first flying machine, an ancient mechanical robot said to have flown 200 meters. He was the first to study flight in birds. The wooden model of the flying pigeon is displayed in Museum of Ancient Greek Technology. Now, robots are manufactured in his name. Eudoxus, a Greek astronomer and mathematician. His most enduring contribution to astronomy was his planetary models and the identification of constellations, thus to the development of observational astronomy in the Greek world. History remembers him as the first to write mathematical explanation of the planets. Eudoxus designed his model of the universe as a series of 27 cosmic spheres containing the stars, the sun, and the moon, all built around the Earth at its center. All the spheres were spinning steadily around different axes. The combinations of these motions succeeded in imitating the actual motions of the sun, moon, and planets across the star pattern. He developed the method of exhaustion in mathematics, a method to find volume and area of geometric figures, such as distant stars and planets, by putting inside a series of polygons with an increasing number of sides. Eventually, the areas of the successive polygons merge to equal the area of the original shape. The method of exhaustion was perhaps taken furthest by Archimedes. By calculating the area of the polygons inside and outside a circle, he was able to show the value of pi in the range of 223 by 71 to 22 by 7. His method laid the foundation for integral calculus. Archimedes used this to discover the area of a circle and sphere, which leads to a field of spherical geometry. Physicists say that 1.3 million Earths can fit in Sun's volume. That is, ratio of volume of Sun to the volume of Earth can be denoted in numbers as 1 to 1.3 million. This is called theory of proportions, as proposed by Eudoxus, that the ratio between two line segments can be compared to the ratio between two numbers or two areas. His theory of incommensurable magnitudes showed that incommensurable geometric magnitudes can bear ratios to one another, that is, no common measure between magnitudes like lengths of the side and the diagonal of a square. For example, ABCD is a square, and it is composed of 4 equal triangles formed by its diagonal. DFCE is composed of 2 of them. Therefore, DFCE is twice as large as ABCD. Now, CD is called the diagonal of the square, whose side is CE. The Pythagorean discovery of incommensurability created a rift between arithmetic and geometry. Eudoxus's theory sustained that rift. Today, such incommensurable relations are represented by irrational numbers. Meton of Athens, another Greek mathematician and astronomer, best known for his calculations involving the eponymous 19-year Metonic cycle, which is a period of 235 synodic months, or 6,940 days, after which the lunar phases recur at the same time of the year. These golden numbers facilitates the construction of a lunisolar calendar, and used in fixing the date of Easter begins at 1 at each year, in which the new moon occurs on January 1st. Callippus of Cyzicus, another Greek astronomer and mathematician, studied under Eudoxus, made accurate determinations of lengths of the seasons, and constructed a 76-year cycle comprising 940 months to harmonize the solar and lunar years. Callippus expanded the work of Meton's 19-year cycle, thought that a year was close to 365 and quarter days, and multiplied the 19-year cycle by 4 to get an integer number of days, omitting 1 day from the last 19-year cycle. Thus, he calculated a 76-year cycle of 940 lunar ages and 27,759 days. Dividing this by 76 years gave an estimate of the tropical year of 365.25 days, later named as Calippic cycle, a duration that has been used ever since. Callippus extended the homocentric sphere model of Eudoxus with 27 spheres by adding 7 spheres, making as 34 spheres system to explain the motions of the heavenly bodies. The Sun, Moon, Mercury, Venus, and Mars each had 5 spheres, while Jupiter and Saturn had 4, and the stars had 1. The world's oldest known astronomical calculator, the Antikythera mechanism, a Greek's technological sophistication, performs calculations based on both the Metonic and Calippic calendar cycles, with separate dials for each. The Antikythera mechanism is an ancient Greek hand-powered orrery, a mechanical model of the solar system, described as the oldest known example of an analog computer used to predict astronomical positions and eclipses decades in advance. Aristotle, Greek philosopher and polymath, one of the greatest philosophers who ever lived and the first genuine scientist in history. He made pioneering contributions to all fields of philosophy and science. He introduced the word physics. It comes from the Greek word physis, meaning nature. As a result, physics was defined as the study of nature and natural events. Physics, in the Aristotelian sense, was a fundamental understanding of matter, change, causality, time, and space. From this, he derived a cosmology that allowed him to explain all phenomena from everyday life to astronomy, including both natural phenomena and technology. Aristotle's general approach became the standard scientific method for about 2,000 years. One of Aristotle's most persistent contributions to science, and indeed the core of his physics, was his theory of the elements. In his view, the elements of nature must represent the fundamental characteristics of nature and must bear the basic properties of matter that drive the dynamics of nature. He believed Empedocles' 4 classical elements that making up everything in the terrestrial spheres: earth, air, fire, and water. He included 2 more tactile properties, active and passive. Matter is more or less dry, hard, or wet, soft, and more or less cold and hot. He paired these properties as dry and cold were the characteristics of earth, wet and cold those of water, wet and hot those of air, dry and hot those of fire, and hard and soft were passive properties. These 4 elements, earth, air, fire, and water, makes up the sensible qualities of hot, cold, wet, and dry. He believed the earth was round, and it is in the center of the universe, also spherical and finite, and that the sun, moon, planets, and all the fixed stars revolved around it. He saw ample empirical evidence of this shell model, which he called its proper place. His explanation of gravity is that all bodies move towards their natural place. His basic observation is that bodies on Earth either rise to a limit or fall to Earth. Heavenly bodies keep moving, without any apparent external force being exerted on them. He distinguishes the circular motion as superlunary heavens and rectilinear motion on sublunary Earth below the moon. Since all sublunary bodies move in a rectilinear pattern, the heavenly bodies must be composed of a different material that naturally moves in a circle without any oppose, which he supposes that as 5th element, ether, quintessence, which heavenly bodies move eternally. He taught dynamics, the branch of physics that deals with motion. Motion and change are closely related in Aristotelian physics. There are natural, violent, and local motion, rectilinear and circular motion. Celestial spheres move in circular motion. For objects according to Aristotle, motion was primarily determined by the nature of substance. It involves a change from potentiality to actuality. He gave example of 4 types of change, namely change in substance, in quality, in quantity, and in place. Aristotle's laws of motion states that heavier objects should fall naturally faster than a lighter object, the speed of which is directly proportional to their weights, and inversely proportional to the density of the medium which gives the resistance. Nothing moves unless it is pushed or pulled, a violent motion. He stated the speed of an object to be proportional to the applied force. Smoke goes straight up, water falls straight down. If cause is removed, then objects returns their natural resting state. He believed that a projectile motion of an object is a combination of violent and natural motion. An object thrown at a certain angle is given an impetus, a force or energy. With that, it will continue to move in such state until the object's impetus is lost, and the object returns to its natural state, causing it to stop and fall to the ground. He believed no body could undertake more than one motion at a time. The path had to consist of 2 separate motions in a straight line. He believed that matter is continuous, and there can be no empty space or void. He is convinced that nature abhors absolute emptiness, and that the universe is filled with an eternal substance called ether. He concluded that vacuum to be impossible, since it would have 0 density, implying an infinite speed of descent. His postulate later becomes known by the Latin term horror vacui, the fear of empty space, and it remains prevalent until the 17th century. Epicurus of Samos, Greek philosopher, and sage who founded Epicureanism, a system of philosophy that says, the goal of life is pleasure. He was an atomist and materialist. Epicurus says we are in an atomistic system, that the basic constituents of the world are atoms, uncuttable bits of matter flying through empty space, and he tried to explain all natural phenomena in atomic terms. Epicurus developed an unsparingly materialistic metaphysics, empiricist epistemology, and hedonistic ethics. The central concept in Epicurean physics: if all matter is made of atoms, and if atoms move through the empty space, he called as void, according to their own fixed laws, then everything that happens to us is predestined. The properties of macroscopic bodies and all of the events occurring can be explained in terms of collisions, reboundings, and entanglements of atoms. Epicurus's metaphysics starts from 2 simple points. 1. We see that there are bodies in motion, and 2. Nothing comes into existence from nothing. He thinks that the universe has no beginning, but has always existed, and will always exist. Epicurus argues that the universe is unlimited in size, and there must also be an unlimited number of atoms, and an infinite amount of void. If the number of atoms were limited, then the density of atoms in any region would effectively be 0, and there would be no macroscopic bodies, as there evidently are. Zeno of Citium, Hellenistic thinker, the founder of the Stoic school of philosophy, teaching Stoicism, which taught that the Logos, universal reason, was the greatest good in life, and living in accordance with reason was the purpose of human life. Zeno divided philosophy into 3 broad areas of inquiry: logic, physics, and ethics. For Zeno, logic is essentially about how we think about the world, both individually and collectively. For the Stoics, physics involves investigating the universe on the understanding that it is both natural and divine. The cosmos as a whole is underpinned by logos or reason. It is an integral aspect of the material nature of the unfolding cosmos. The reign of Aristotelian physics, the earliest known speculative theory of physics, continued in Hellenistic period and lasted almost 2 millennia. After the work of many pioneers such as Copernicus, Tycho Brahe, Galileo, Kepler, Descartes, and Newton, It became generally accepted that Aristotelian physics was neither correct nor viable. From Socrates to Aristotle, called as the period of highest perfection, with the opening of the post-Aristotelian period begins the age of decay and dissolution. We will go through post-Aristotelian philosophers in the next coming videos and the birth of Newtonian physics in detail. Let our gravity attract you. Stay with us. Thank you.